Children, this is screw gauge. You all would have learnt in your intermediate. You know, a screw gauge has got a head scale. You can see the markings here, which can be rotated. That's why it's called the head scale. If I rotate the head scale, you can see another scale here, which is your main scale or pitch scale. And each reading on this main scale is 0.5 mm. Okay. Now, initially you have to keep the two heads together without a gap. This way. Then the 0 of the head scale should coincide with the 0 of the pitch scale. It means there is no error. Right? Next. What is least count of an instrument? It is the least value which this instrument can measure accurately. That is the definition of least count. Now, how do we find out least count of this given screw gauge? You have to rotate this once so that 0 comes here. Then you can see one division, that means 0.5 mm, you can see. Right? Now, if I rotate once again, I can see two divisions. That means I can see 1 mm for two rotations. Therefore, the pitch scale value is number of divisions on pitch scale divided by number of rotations of head scale. And this is 0.5, what I did the first one, for one rotation, number of rotations. Therefore, the pitch scale value is 0.5 mm. Now, I know the pitch scale value. I have to calculate least count. Least count is this pitch scale value divided by number of head scale divisions. That is 0.5, and there are 50 divisions, as you can see here, 50. Yes. So, when you cancel, how much do you get, children? Do I have to remove the decimal and show you? It is 0.01 mm. This is the least count. Now, why are we using this? Our experiment is to find out the rigidity modulus of the given wire using torsional pendulum. Now, where is the wire and where is the torsional pendulum? Come to the wire. See, this is a wire here. We have to find the rigidity modulus of this wire, and this is the torsional pendulum. Now, we have to find out the radius of this wire using screw gauge. And to find the radius, see, this is how you have to fix the wire between the two ends of this screw gauge tightly. Find out the pitch scale reading, and here it is just one line, so 0.5. Okay? Or if you get 0, that means if you cannot see any line, you'll write 0, whatever it is. Next. Head scale reading means which line here is coinciding with the main line. How much is that line? That line is approximately 47 to 48 because this is 0. 43.
0.3 main scale.
So children, this head scale reading is 49, which is coinciding with this horizontal pitch scale line. Head scale division 49 is coinciding. So you will note down pitch scale reading was, you could see only one line, 0.5 mm. Head scale reading was 49. Multiply it with least count. Then add the two columns A plus B. 0.5 plus 0.49. 0.99.
50.
So this is the radius of the wire, which is denoted by small a. Okay. The length of the wire with a meter scale from here to this point to 50 centimeters. That is shown in the first column. 50 centimeters should be the length of the wire from this point of suspension to this torsional pendulum. Next, what you have to do is make some mark here with a chalk. You will be given a piece of chalk and oscillate. That will come back. 1. Again it will go back and come back to that point where you have marked with the chalk. 2. It will go back and again come back. 3. This way you have to take the time for 20 oscillations. That is trial 1. Similarly, trial 2. Then the average of those two. Then time period for one oscillation divided by 20. That is capital T. Then find T square. And the last column is L by T square. L is whatever length of the wire you have taken. 30 centimeters, 40, 50, whatever. L by T square. Now you have to calculate the rigidity modulus of this. It is denoted by eta, Greek letter. It is, the formula is 8 pi square by a power 4 into m capital R square by 2 L by T square. Now what is A? We have calculated. It is the radius of this wire with a screw gauge. Okay. L by T square you know from this column. For each column you have to calculate eta, children. Each column. Now what is this capital M? It is the mass of this. It is a heavy thing. You have to be careful while doing the experiment. You have to keep it on the spring balance and find out the weight. We will tell you the weight. Okay, but that is the mass. Next. You have to find out the radius of this disc. You have to find out the radius of this disc with a thread this way. Till wherever it is, and measure it on a scale. Show them how much it is. See how much it is.
43.5.
44. Okay, so this is 44. So you have 2 pi into capital R as 44. Now why am I taking this formula? Because the disk is circular and the circumference of a circle formula is 2 pi R. From here, calculate capital R, and that is what you have to substitute in these formulas. So you know 8 pi A, radius of the wire, m, mass of the disk, r, radius of the disk, L by T square from your tabular column, and hence you can find out the rigidity modulus. So with this experiment is over. Thank you.